Hope you're doing great. This is Maria Pandirajan, your friendly software engineer. And in this video, we're going to talk about classes in C++. So, classes enable us to create objects, alright? But what are these objects? So that we need to define what an object is in order to understand, what a class is, because classes enable us to create objects, right? So, objects are anything that have properties attached to them, right? So that's what we can define an object to be something that has some kind of properties and a bit of functionality attached to it. And now the cool thing is we as human beings live inside an object oriented world, right? What do I mean by that? Now if you look all around you, right, like anything and everything that you see is an object, right? It can be objectified if you will, right? Like everything is an object. Everything, like let's say for example this remote control that I have in my hand, this can be considered as an object because this has some properties to it, right? So it's got it's got a rectangular shape, it's got some buttons, it's got a color. You can define what are all the different properties that this particular object has. So anything for that matter, like this kerchief, it's got like it's an object, right? Because it's got some properties attached to it. And anything like this cover, whatever that you can see all around you, right? Like anything that has properties, right? Anything that you can like let's say I have this phone with me, so this is an object, right? Because this phone it's got a color, black color, and it's got like a size, it's got weight, so this is an object, right? So that's why you call something like a phone you call this an object because it's got properties attached to it, right? You can define this object by means of the properties and the functionalities that it has. So anything and everything that you can see all around you, right, in this world that we are living in is an object, right? Even as human beings, we can also be considered as an object, right? Because I can be considered as an object, right? Like so basically, like I have certain properties. There's a skin color that I have two eyes, like I have like some hair so you can define me also. You can basically objectify me, if you will, saying that these are the properties that make this particular person, right? Like same with you and same with anything that is around you. So everything in this physical world that we live in is an object. It can be considered as an object because you associate a name to it and that that particular object will have certain properties. Now that's what an object is. An object is anything that has a bunch of properties and functionality associated with it. Now in order to design such objects, right, so in order to design a particular object, we can make use of classes. Okay, classes can be considered as a blueprint, like the design spec, if you will, for creating objects. See, that's what a class is. Now as an example, right, like so I have this Thanos hand toy with me. So it's just a a cool looking toy, and this Thanos hand is an object, right? As everything else in this world is an object, this is an object. So let's define this object. Okay, so this object it's got a color, like maybe we can call this as a bronze color. So it's got a bronze color, and this object has a bunch of lights on it, right? So these are all like it's got one light per finger. It's 1 2 3 4 5. It's got 5 different color lights, and it's got this nice big button. All right, so these are all the properties. I'm just defining the properties. So this has got a color, bronze color, and it's got 1 2 3 4 5 lights. So it's got 5 lights, and then it's got one button, right? So there's a nice button which is also a light. Now the cool thing is, if you press this button, right, it lights up. All the lights light up, and it produces some kind of a sound. Okay, and if you press the button once again, it stops. So that's the functionality that this object holds, right? So now this object, right, and it has a bunch of more properties. Obviously it's got some dimensions, it's got a height, it's got a width, and it's got weight and all those things. So like let's try to create this object. And we know that this particular object, right? So this is, since it's a toy, this is not the only piece of Thanos hand toy in this entire world, right? So obviously there are much many replicas, much many copies of the same toy, right? Like, and obviously, like, we bought this from a toy shop, so obviously in the toy shop rack there were several of these lined up, right? So and all of them had the same specifications. All of them had, all the Thanos hand objects in that toy rack had exactly the same specification. They all had the same color, bronze color. They had the, these 5 lights, and they had this nice button which when you press, makes the sound. Everything did the same thing. All the objects had the same properties, and that's why we call them Thanos hand toy, because if it's a Thanos hand toy, it needs to have bronze color, it needs to have these 5 lights, and it needs to have this button, right? So that's how you define that this is that particular type of an object. Now, in order to create these objects, we know that there was one mold, right? Like, there was some kind of a specs document somewhere out there, like by some kind of a toy creator or somebody who creates toys. He had created this design. He had created how he wanted this, objects, Thanos hand toy objects to be. So he had spec them out. He had like designed them, saying that, okay, this is what the color should be, and this is maybe like they should have some 5 lights, one in each finger, and it's got nice to have this nice big button and all those things. So he designed this, right? So that was a spec document. Now that spec document that the toy maker created was not the toy. It was not the object, right? It was just the spec. It was just the, it just defined the class of objects that you wanted to create, right? So that by itself, the class by itself, or the spec document by itself, the blueprint by itself is not the actual object, right? But that is the most critical piece of information that you need in order to create objects such as this, right? Using that spec, using that blueprint, you can create any number of Thanos hand toy objects, right? So that's basically like what we are doing when we are having a class, right? When we write a class, we are creating that spec document, that blueprint, right? And using that spec document, you can create how many number of objects that adhere to that specification that you have defined in the spec document. That is the class. So that's the relationship between a class and an object. So the class is basically a spec document, and using the specifications, the properties and the functionalities that you define on that class, right, that spec document, you can create instances of that class and create how many ever number of objects that you want, right? So that's basically what a class and an object is. So now let's see how we can create a digital version, digital object, digital Thanos hand object. Okay, so we're going to see how we're going to create a Thanos hand class, right, which is the specification, and using that we'll also create a couple of objects, digital objects. Okay, so that's what we're going to do today. Okay, let's get started. So now, first of all, we need to define that class, right? So before we can create an object, first of all, we need that specification. We need that, spec document, which is basically the class. And in C++, this is how you create a class. You just say class. So that's the syntax. And then after the saying class, you need to tell the name of the class. In this case, it's going to be Thanos hand, right? So that's what we want to do. Thanos hand toy, right? So this is the class of Thanos hand toy. Okay, so this is the name. This you just give whatever you want. Okay, so and this is you just need to prefix it. You should have the word class in front of it, and then open the curly brackets and close it, and then you need to end it with a semicolon. All right. So everything that you're going to add inside this block, right, belongs to Thanos hand toy. Okay, so so basically this Thanos hand, they are going to be basically the properties, right, that's going to associate with this particular Thanos hand toy. Okay. So or we just call it Thanos hand just to keep it short. Okay, so this Thanos hand is going to have a bunch of properties. Okay, let's just define them now. We know that it's got a color, right? So let's just use a std string, right, so to hold the color information. So what we're doing here is basically we are creating a variable. That's pretty much what we're doing, right? So we're creating a variable called color, and we're going to assign it, so what color is this? So it's maybe bronze color. Okay, let's just put it, call it bronze. Okay, so bronze, right? So yeah, so basically we just using a string here to store the color of this particular Thanos hand. Okay, so what we have done here is essentially, we have created a variable. So that's what we have done, right? It's just a, like we have just specified a place in memory where we have just, storing this color information of Thanos hand. Okay, so that's what we have done here. Now, the thing is, this particular variable that we have created, right, inside of this class block, by default, inside of a class, this variable, this property that you have created will be private. Okay, so what does it mean to be private? Because, like in C++, when, so basically the same variable, if you had created inside of the main block, you can just access it, right? You can just, call it, you can just use a stdc out, and so we will be able to print it out, right? We know that we can do this, right? So we can print it out, right? But this variable that is inside, that has been defined inside of a class, by default it would be private. So what does it mean to be private? So private means you can't access it when you create an instance of, like by default, when you create an instance of this Thanos hand, that is when you create an object of Thanos hand, this color property would be hidden. It won't be exposed to the people who are using that object. Okay, so it'll be more clear when we actually see this. So let me just clear these things in the main function. And so basically, yeah, so we have this color variable that has been defined inside of Thanos hand, right? So what we'll do is we'll just create an instance of this object. We're going to create an instantiate. We're going to actually create a object right now. Okay, so because here it's not yet an object, it's just a specification, okay, of how a Thanos hand should be. Now we are going to create an object. So to do that, it's just as simple as how you would create an any other data, like a data type, like or any other variable. Like for, if you want to create an integer, what you would do, you just specify the data type, like to be int, and then you'll say number is equal to 10. So this is how you like basically create a variable called number, which is with the data type int, and assign a value to it, right? So it's pretty similar. As a matter of fact, you can even do it like this, right? So you can just say, okay, I need a variable called number. I need an integer variable called number. So if you do, when this is, when the line 10 is executed, that itself will allocate a couple of bytes for you, like basically whatever the space of integer is, it will allocate that space to hold integer variable in the stack, right, in your memory. Now, and then like the next line also, you can just say number equal to 10, yeah. So and assign a particular value to it, right? So this is, we know this, okay. So what we're going to do is we're going to do something very similar to that. So instead of specifying int as the data type, we're going to say we want our data type to be Thanos hand, because this is the class that we are creating, right? So this is the Thanos hand that we are creating. So the data type, this is a Thanos hand. It's not just a integer variable, it's a Thanos hand. So, and we need to give it a name, right? So we'll just say, we'll just call it maybe Thanos hand of Raj. Okay, so this is Thanos hand of Raj. Okay, we're going to create a Thanos hand of Raj. Okay, maybe that's this toy this guy called Raj is buying over. Anyway, so you can give whatever name you want, like this is a variable, right? So and then this particular, so now in this line, it's a line number 10. We have literally this particular line, when it gets executed, it creates that object. You have an object. Okay, so that's it. That's how you create an object. It's that simple. So here you have defined a specification. You have defined the specification for Thanos hand class, right? That it will hold up one property at that moment called color, and then to instantiate, to actually create that object, you just need to like mention the data type, the class name, and then the name of the variable that you want to give to it. Okay, so here it's called Thanos hand of Raj. Okay, so let's just like, okay, that's cool and all, that's fine, but how do we retrieve the property of this particular Thanos hand of Raj, right? So how do we get the value which we have assigned here? So if we actually do that by means of using the dot operator. Okay, but here when you see, when I clicked on dot, nothing happened. It's not like allowing me to access the variable that is inside of this class. Like even if I like say color over here, and try to print it out, right? So it's not going to be allowing, it's not going to allow me to do that, because like as I told earlier, right, this variable, anything that you define, any variable, all the properties that you define inside of a class by default will be private. Okay, it's as if there is literally, that is what is happening. Okay, so it's as if there's this tag called private which has been like added on top of it. That's what actually happening. So by default everything is private. Okay, so in order to make this, in order to expose this to the outside world, as in like in order to expose this to the people who are creating the objects, right? After our object is created, if you want to access those variables, we need to explicitly mention that these things are public. Okay, so you need to have a tag called public. Okay, you can even have, okay, we'll have a thing called private as well. There's another thing called protected. We'll talk about it when we do inheritance, and when we later in a session when we talk about inheritance. But now these things are much more relevant to us. So we have, so like you need to define what are the variables that you want to be public. So that means when an object is created of that particular class, what are the things that you want people to be able to use. So in now you can see that squiggly red line is gone, right? So and like as a matter of fact, if I use the dot operator now, see that particular property is now exposed. We are able to access it. So we can just say color, and we can print it out. See right now under private I don't have anything. Like later on when we actually we can actually put things which we don't want to expose under the private keyword. Okay, so anyway, so like let's just run this and see. Okay, so let's just, if we run this now, what we have done, we have just basically defined a class here, okay, which has got just one variable which is public, and then we have created an instance of that class, and we are printing at the property of that object. Okay, so which is the color property, we're printing it out. Okay, so we'll just compile and run this and see if we are able to print out the color bronze, right? Yeah, cool, like that's awesome, right? So we are able to now print out the color of our object, right? Like the color of our Thanos hand object, right? So cool. Like as a matter of fact, we'll just call it Thanos hand here. You can call it whatever you want. It's up to you. Just for convenience, you just call it. And by convention, right? This is not like a rule or whatever, but by convention, we use this capital casing for the class name. Okay. And I personally prefer using the capital casing along with capital snake casing, I guess this is called. So you just like separate each of the words by using an underscore. Okay, so this is capital snake casing. Some people use capital camel casing. So if, instead of underscore, if you just write it together, it's called camel casing. So personally I prefer snake casing. Okay, because it just separates the words and it's easier to read. Anyway, so the class names usually will have capital camel casing. Well, like you can, that nothing is stopping you from doing this as well. Okay, so this is also completely valid. You can do this as well, but it's better to adhere to convention and use the capital names for the class name. And then for the object names, you can use the smaller casing. Okay, so in this case it's convenient, right? Because it's you just call, you're creating an object of Thanos and Thanos and, okay, just maybe Thanos on 1. Okay, so so that this is first Thanos hand that you're creating. Like, because let's say you're like in a toy shop, there are like 100 Thanos hands that are required. Okay, so this is the first Thanos hand you're creating, Thanos hand underscore 1. And yeah, and the objects usually will have a smaller casing. Okay, so that's something that we need to keep in mind. It's just convention. Okay, nothing is stopping you from creating something with the capital as well. But yeah, don't do that, because like, yeah, it's better not to do that, because like most of the people are writing code in this way, following this convention. So it's better to follow convention, especially when you're participating in collaborating with the other developers and other software engineers. Anyway, cool. So we can see that in Thanos hand 1 dot color, we are able to access this particular property from outside. This is very interesting, right? So now we have an object which has a color. Cool. But we know that Thanos hand here has much more properties, right? So we'll now add a couple of color lights to it, right? So we know that there are 5 lights. One is purple, and actually one light here is missing, but anyway. So purple, green, blue, yellow, red. We'll just put some certain colors to it. Okay, so we'll just say, okay, so let's say we'll have a boolean to signify whether a particular light is on or off, right? Because by default we can see all these lights are off, right? So let's just have a boolean saying color, red color. So what's the first color that we have here? It's a purple color, right? So purple color, purple light equal to it's off, right? It's a boolean, so we'll just say false, right? So purple light on, we'll just keep it, we'll name the variable more in a descriptive manner. On, purple light on, no, it's false, right? False means it's off. So, and then what else colors we have? Purple, then we have blue, and we have green, and then we have purple and red, and let's say we also have I think, yeah, cyan color. So we have these colors 1, 2, 3, 4, 5 colors, each light for 5 lights, each light for each finger. cool. And then like we also are gonna have like one button, right? So that's also, we'll just use a boolean just to hold it, okay, whether know whether the button is on or off, right? So we'll just have one yellow button, and we'll set that to be also false. Right now it's not, like you're not pressed it, right? So if it's true, means that means the button is pressed. If it's false, means it's not pressed, right? We'll just keep it very simple. So that's it. These are all the properties of this Thanos hand. Okay. As a matter of fact, like it makes sense to put all these lights to be it makes sense to keep them private. Yeah, let's just make all these lights private, and the button alone will make it public. Okay, because you don't want people to directly go and change the like individually. You don't want to people to allow you don't want to allow people to individually switch on or off any of these lights, right? Because this object, that's the beauty of this, right? So here, this object here, what they have exposed, when you have this object with you, all you can do to interact with this is press this one button, right? So if you can only press this yellow button, if you can see this, yeah, yellow button. And if you press this yellow button, then like all these lights will turn on and it'll make the sound and all this. But you don't have an interface to turn each of these lights on or off individually. So that's something that even this this toy maker has been consciously has consciously designed into this object, right? So we can do that same thing in our digital version of the Thanos hand as well, right? So here as well, all these light switches, right? It's essentially a switch, right? Like the purple light, blue light, green light, red and cyan, all these lights, you don't have an interface. You can't directly turn them on or off. You can't use the Thanos hand one and use a accessor to there's no property here, right? It's all hidden, right? So you can't change the state of these lights directly. You only have the button exposed to you. Okay, so you only have the button and maybe the color as well. As a matter of fact, even the color we can actually make it private, right? Because when you think about it, you can't change the color of this Thanos hand. You always want this color to be bronze, right? So like we'll keep that also to be private. So the color of this Thanos hand is also it's private, and you have a bunch of these lights, right? Perfect. So only thing that is exposed, that's public, is the yellow button. As a matter of fact, what we usually do is that the variables, we usually put that also to be make it private, and then we use a helper function. Like basically we just create a function. So till now we only created a bunch of variables, and so we know that we've already seen how we can create functions, right, in a previous video. So like we can create a function here, like functionality, because this Thanos hand has one functionality, which is basically where you press the button, it'll turn all these lights. So we'll just define that function. We'll just call this so it's not going to return to us anything, right? It's just going to like turn yellow button pressed. Okay, we'll just say yellow button press yellow button, right? So that's the function. Press yellow button. Okay, so this is that function. And yeah, like we'll just define that function here. So we'll just call we'll just say what should happen when you press yellow button. So basically it should say yellow button equal to true. Yeah, because you can access this value because this is inside of this class. Like all these things are happening inside of this same class context. See, there's this curly bracket. This is this curly bracket is happening. We can break things into break the class into header files and source files. We'll be doing that later, but for now, we'll just keep all these things in a single file, okay, just for convenience. So yeah, so basically like all this does when you press this button is just sets this yellow button boolean to be true. And another convention, like which is good, is basically like just put an underscore, having an underscore, okay, like in front of all these private variables. Okay, so just to know that this is a private variable, it's good to put. This is coming from a Pythonic way of doing things, but anyway, so it's just putting an underscore in front just by reading. I mean, you can just to signify, you don't need to do that. Okay, it's just a convention. If you want to follow, you can do that. Just like by putting this underscore in front, we just signify that this particular variable is actually private. Anyway, so here we'll just say underscore yellow button is equal to true. Okay, this private variable, we are setting it to true, and we also need to set all these things to be true, right? So we just copy all this over here, and all these variables, we want to set them all to be true. Cool. And now the thing is, this should be turned on the first time, and when you press it again, it should be turned off, right? So you need to have some kind of a logic here in order to do this. how do we program this? Like, let's say maybe if we can have some kind of a if statement saying, if it's already pressed, then we set it to off. So maybe we should have another variable here. Oh yeah, like we can use this, right? Yellow button pressed. That's the reason we have this, right? Yellow button pressed. Okay, so by default the yellow button pressed is false. Okay, so we just rename this to yellow button pressed. Okay, so here what we'll check is if it's not pressed, we set the like yellow button pressed boolean to be true, right? We set it true. That means it is now pressed, and since the button is pressed, we set all these lights to be on, right? We set all these lights to be on, right? And if else, that is if the button, if you press if you're pressing the button again, that is like if this press yellow button is called again, we check. What we do is like we'll check if the yellow button pressed is true, that is it is already pressed. If it is already pressed, means that we need to revert this option, right? So revert all, we should turn off all the lights. So we can do that by having this else statement, right? So because a boolean can have either true or false, right? So if it's false, we set it to true and turn on the lights. If the previous state was true, that means we need to set the state to be the yellow button pressed to be false, and we need to turn off all the lights. So we'll just do that. So else, cool, that's it. So now the cool thing is, so we have a logic here. Okay, so we just let's zoom it out. So basically this is our logic that we have inside of this press yellow button function. So when you want to press the yellow button, you just call the press yellow button. So here in the physical world, you actually can take your finger and press it literally, right? And I'll press it back once again. Turn off. Yeah, right. But in a digital world, right, you need to have a function, right, to call, to do that functionality for you. So this is the function that we call, and when you press it first time, like by default, we know that the yellow button pressed private variable is false. So since it is false, we set it to be true because you have pressed it. So that means it is just pressed. So that means it needs to be set to true, and then we turn on all the lights. Okay, we just turn on all the lights. Then when if you press the function, if you call the function another time, the second time, what we're going to do is like the second time around, since the yellow button pressed would already be true, we are setting it to be false, but that is it's turned on, it's no longer pressed, so we set it to false and we turn off all the lights. So that's basically the logic. That's literally the logic that is here that is available in this particular object, Thanos and toy, this particular object that we see in the physical world. So cool, this is really cool. Now what we'll do is we'll also have a print statement or something to see the status of this toy, right? Because like in the physical world, we have eyes to perceive this object. In the digital world, we also need some kind of a status mechanism, right? So some kind of a mechanism where we can understand what's the current state of this object. So what we'll do is we'll just like have some kind of a print statement, print object status or something. So print object print status, because we already instead of this, so we'll just print status. It's also not going to return anything back. So here we'll say if the light is on, we'll just say print. Okay, print. I'll just make this zoom in a bit. Yeah, so if the purple light is on, see out. Obviously there is better ways of doing this. We are writing all these lights again and again. This is not good programming practice, but just to make a point here. Okay, so we'll just use this. So if the light is on, we just say print purple light on. All right, and stdc out, and else. And another cool thing in C++ is if your condition is just if your condition statement is just one statement, right, you can just put it under here without a bracket. Okay, so that's something that is useful. So else, it should just be off. Okay, so else the status would be, so this is on, otherwise it's off. So we just need to do the same thing for the other lights as well, right? So we just, all right, cool. So we have all this, we have a bit of logic here as well to help us to print the current status of the lights, right? So print status. So here basically what we'll do, print light, if the purple light is on, basically this we are using this private variable, right? So if this private variable purple light is on, we just print purple light on, otherwise we set print it to be off. Blue light is, if the boolean is on, we print on, otherwise off. Basically we're just using the states that are there, current boolean statuses, and we're just printing the corresponding lights, whether they are on or off. Again, there's much better way to do this. This is not how you actually write the logic, but just here to make a point, we're just like putting these prints, like just directly hard coding all these things here. Okay, anyway, so Yeah, like cool. So we have this print status as well. Perfect. Now let's actually create an object. Okay, so let's just create our. So we already have created an object, right? So let's just use it. Okay, so we have a Thanos hand now. Now if you print the status initially, right? So let's just see what's going to happen, right? So we just got a semicolon. So if we compile and run this, we can see that all the lights will be off. Right? So we should see that the lights are all off. Yeah, see, purple light is all these lights are off. Okay, cool. And we can also, along with the status, we can also print maybe the color, right? And yellow button. So here again we have another logic, so which is basically for the yellow button as well, right? So yellow button pressed. If yellow button is pressed, that means yellow button is, this is just an indicator for us to help us to a yellow button is pressed. Else we just say yellow button is unpressed. Cool. Perfect. That's it. So let's just, so yeah, we're going to print, we are literally printing all the properties and the functionalities of this particular object. So this is basically like our eye into this digital world. Anyway, so by default, when we print the status and, like, let me just compile and run this, we'll be able to see that, like we'll literally be able to see the current status. See, just like how we see in the physical world that this is bronze color and, like this yellow button is unpressed, it's not pressed right now, and all the lights are off, right? So you can see it in this physical world, right? Like just like that, in this digital space, we can see that, like the color is bronze, just like how this color is bronze, and like the yellow is unpressed, yellow button is unpressed, and all the lights are off. Perfect. Cool. This is interesting. Now let's interact with it. So in this physical world, when you press this, all the lights are turning on, right? Like this is actually happening. So now what we'll do is, like in the digital world, in this digital Thanos hand object that we have created, let's press the yellow button, just like how we press this yellow button here in this physical world. So we're going to do that now. Okay, let's just go here and we'll just say Thanos hand 1 dot press the yellow button. Okay, let's see what happens. I'm excited. So press yellow button. Now after pressing the yellow button, we need to see what's the status, right? So we'll just again print the status, right? So now all the lights should turn on, it should get lit up, right? So let's see, let's compile this and run. And yes, right, see, initially all, like initially the color was bronze and, it was unpressed and, all the lights are off. Then, like when we call the function again, right, like or rather, yeah, like when we actually call the function, this is the first time we're calling, right? So yeah, this is the first time we're actually pressing the button. So when we actually press the button, you can see that, the property, yes, the color is still bronze and the button is pressed and all the lights are turned on, right? So that's awesome, right? So it's the same object. You're not, see, it's literally the same object. It's just that now the object is in a different state. All the lights, have turned on. So that's pretty cool. As a matter of fact, let's just put a small, separator here. Yeah, we can maybe put that inside of the sprint status itself, right? So in the sprint status itself at the beginning, let's just have a small endl. Yeah, we can actually, yeah. So let's just say steady cout, and we'll have, yeah, as a matter of fact, we can actually have a new line character here. Right? Yeah. So this will basically introduce a new line character so that we can have a line break. Cool. So this is pretty cool. So we have pressed, when we press the button first time, all the lights are, turned on. So we can see all the lights, it's pressed and it's all turned on, right? So this is perfect. Now let's press it once again, because here in the physical world also, when the, it's working, and when you press it once again, it turns off, right? So that's, let's see if that happens in our digital Thanos hand object, right? So let's just call this function once again and print the status again. So the second time when you call the same function, it's the same function from a user's perspective, of this user of this object's perspective, you're literally interacting with it the same way that you would, with the physical Thanos hand object, right? So now let's compile and run this. Let me just close this terminal and let's just compile and run. And yes, I mean, like, this has to be expected, right? See, this was the initial state before we even pressed this button. And then, like, we pressed the button. We actually pressed the button, and when we pressed the button, like, all, the yellow button was pressed and all the lights were turned on. And again, when we pressed it the second time, the color is now, still bronze, and now it became unpressed, right? And all the lights turned off. So that's pretty cool, right? Like, so what we have done literally is, like, created a digital object of this Thanos hand using, like, a class. So that's what classes enable us to do. So I just like zoom it out and just to show you a bird's eye view of what we have done. So yeah, you can see that this is a class. So where is the class? So here, from here. So as a matter of fact, I'll just close these functions to give you an idea. So yeah, so this is the class, right? Thanos hand, and the Thanos hand has got two functions. One is the press yellow button. Both are public. Press yellow button and print status. Both are public. And then like you have a bunch of private variables, right? So to keep track of what's happening, because these things don't need to be exposed to the user because they shouldn't be interacting with it directly, right? That's how it is over here also, right? Like, as a matter of fact, like there's a small hole here. I don't know whether you can see it. There is a bit of a circuitry that's here. Yeah, I don't know. Yeah, like, so there's a bit of circuitry that's controlling all this, right? So that's not exposed to the user because you have this nice facade, you have this nice mold, and even if you look inside, it's all packed inside, right? So this that is not exposed. That's all private to this object, right? So the only way to interact with it is using the public interface. So the public interface is this button, right? So this is the only button. This is the public thing that you're using in order to modify the private state of this object so that you have a nice UI. I mean, like nice user representation, right? Like user interface, show lighting things up, and you're able to interact with this using a single button and not just the individual private components. So that's essentially what we've done. So we have all these private components, right? And but we interact with it by using the public component, which is like the press yellow button and the print status and so on. So yeah, so that's basically what a class is, and using that class we were able to create an object. This is how you create an object of the class, and you were able to also interact with it, right? So that's pretty cool. So this is what a class is in C++, and I hope this video was useful. Thank you so much for watching, and I will see you again in another video. Cheers!